Most of your mathematical lives, you've been studying real numbers. Real numbers include things like 0 and 1 and 0.3 repeating and pi and e, and I could keep listing real numbers. These are the numbers that you're kind of familiar with. And then we explored something interesting. We explored the notion of, well, what if there was a number that if I squared it, I would get to negative 1? And we defined that thing, that if we squared it, we got negative 1. We defined that thing as I. And so we defined a whole new class of numbers, which you could really view as multiples of the imaginary unit. So imaginary numbers would be I and negative I and pi times I and e times I. So this might raise another interesting question. What if I combined imaginary and real numbers? What if I had numbers that were essentially sums or differences of real and imaginary numbers? For example, let's say that I had the number, let's say I call it z, and z tends to be the most used variable when we're talking about what I'm about to talk about, complex numbers. Let's say that z is equal to the real number 5 plus the imaginary number 3 times I. So this thing right over here, where you have a real number plus an imaginary number, and you might be tempted to add these two things, but you can't. It won't make any sense. These are kind of going in different, well, we'll think about it visually in a second, but you can't simplify this anymore. You can't add this real number to this imaginary number. A number like this, and let me make it clear, that's real, and this is imaginary. A number like this we call a complex number. A complex number. It has a real part and an imaginary part. And sometimes you'll see notation like this, where someone will say, well, what's the real part? What's the real part of our complex number z? Well, that would be the 5 right over there. And then they might say, well, what's the imaginary part? What's the imaginary part of our complex number z? And then typically the way that this function is defined, they really want to know, well, what multiple of I is this imaginary part right over here? And in this case, it is going to be 3.